Hi, my name is Shane, and you're watching part 2 of my multi-part series about home automation. In this video I'm going to talk about home automation design. So when you start designing a home automation system, you've got to have a goal in mind. In my case, I didn't really have a goal. It was just, I really like automation and I want to learn programming and a few other things. So I just started along that path. When building an automation system, you also need to think about why do you want an automation system? Why do you want to automate stuff? Is it going to make my life easier? Is it going to make my life harder? I can say with my system it's done both. It makes a lot of things easier, but also recently I had a friend stay over and they slept in the lounge. And my house has got motion sensors which are connected up to the automation system, which is very, very helpful at night because it turns on a series of lights when you walk to the bathroom or the kitchen or whatever. But my friend was staying in the lounge and he kept moving and the motion sensors would pick that up and turn all the lights on. So the next morning, I wake up and I go and, I see him and I'm like, hey, how was your sleep or whatever? And he's like, hey, the lights kept me up the whole of last night because every time I would move just a little bit it would be like, poof, like daylight in here. So I did tell him he was quite a bit of an idiot. Just to not tell me, like he should have just said, hey, woke me up, tell me, and I would have been able to turn them off. But stuff like that. So the system, if you automate it too well, can't predict it can't handle like unpredictable situations or something that doesn't happen often. Another thing you want to look at is, do you want to gather statistics? In my case, I wanted to gather statistics. So everything in the entire automation system, from when motion sensors are triggered, to when buttons are pushed, to when operations are done, is logged. And the reason I want that is because I am busy working on a way to tie it in with Google's prediction algorithm, but also just so that I can see what part of the house is being used, what are we actually using the automation system for, what are we not using it for, what can we improve on, and stuff like that. And then the third thing is like, are the other reasons? Do you want to save money and stuff like that? Or what is your reasoning? I would say you should probably get up with a good reasoning because it is going to cost you money in the end, and you've got to obviously justify that expense for the reasoning. So there's different parts to the system, and I kind of have them kind of separated, but they're actually together in most cases. It's the software and the real world. So there's a lot of stuff that will happen in software which isn't physically there. It's a piece of software, and then there's a lot of stuff which is just the real world, which is physical stuff like wiring and physically having buttons in place and stuff like that, and then also how that integrates. So in my multi-part series, I'm trying to go through everything from all the software to all the real-world stuff. So let's start off with the system that I've got in place. I'm just going to give you a bit overview of the system. So I have a network in my house. I'm using Microprocessor or Microprocessor, depending on how you pronounce it, gear throughout the house for doing Wi-Fi and my IP networking. And the reason I chose that platform is because it's very robust and you've got a lot of flexibility. Like you can limit certain networks and you can have VLANs and a whole bunch of other stuff, and it's very, very cheap for what you get. So this is kind of just a network overview. I've got microprocessors with Ethernet shields, so it's basically Arduino Unos or Arduino Megas with Ethernet shields that allow them to connect to the TCP/IP network, which is normal home network. So I've got 4 of those in place. And actually, like the number 3 and 4 are kind of come and go depending on, they're kind of my experimental ones. 1 and 2 are physically always there. And then I've got a Raspberry Pi, which I use as like my central computer and also my input computer. And it also runs all the actual scripts, the Python, because I'm using Python in this case, Python scripts which do all the automation and all the logic for automation. Then in this network, I'm just showing you that there are normal computers on the network, but actually, which you can't see in this diagram, is that they're actually isolated from the home automation. And the reason for that is because I'm using MQTT to actually communicate between everything on the home automation network, which on the Arduino side, the Arduino isn't powerful enough to handle any type of encryption, so it's quite unsecure. So if you're put in a completely separated, isolated network, that helps a lot with that. But for more like mission critical stuff like doors and stuff like that, I use Raspberry Pis to activate that because they actually are capable of doing proper encryption. And then I've also got some servers on the network, which can be Raspberry Pis. On the Raspberry Pi, I kind of separated because of network and security with the isolation. but it can be, and I have tested it running on the Raspberry Pi itself, and it works fine. Just there's a lot more configuration needed on the Raspberry Pi itself to make sure it's secure, and I didn't really want to do that, so I've actually got a separate server which has also got a bit more beefy processor and stuff like that. And the server side just handles, basically hands up a web interface to all the clients, like the normal computers, the cell phones, iPads, the wall tablets and stuff like that who need a web interface. So let's quickly go through a quick example. If you push a button to turn the light on, what will happen is the button at the the button's attached to a microprocessor. When you push that button, the microprocessor gets a message, and it will pass it on to the network. So now it will send it out, and it will send it all the way to the Raspberry Pi, because the Raspberry Pi is the MQTT broker, which I will have a video just on MQTT, but the MQTT broker is essentially like the MQTT server. It will send it this message, and this message will basically be like button press with this ID, and the Raspberry Pi will then look up in its database and see if this button is pushed, what must I do, and it's like, okay, cool, I must do this, and then it will do that, and it will send out another MQTT message, which will then run to microprocessor 2 in this case, and it'll tell microprocessor 2, hey, I need you to turn on this output, and then it will turn it on, and I'll show you later the physical circuitry which I've in place, and it'll basically turn on the light. Now, because I'm using an IP network, there's actually a lot of flexibility that I have, and that's the fact that I can also use a normal computer and access a web interface, which is through the server, and I can choose to turn on the light, and the server itself will send an MQTT message to the Raspberry Pi, like so. And the Raspberry Pi will do the same thing. It will look up, hey, I've been received with this button ID, what must I do with it? It will check in its database, do its processing, because there's a lot of things it can actually do. The logic in my house at the moment is quite complex, but it's really, really awesome. And it will obviously then send the command to turn the light on or turn the light off. So now onto a bit of the hardware. For this basic example, I've basically got a button connected to a Raspberry Pi. That's what's running at 3.3 volts. So basically when you hit the button, it sends it pulls one of the microprocessor's pins to 3.3 volts, positive 3.3 volts. And on the output side, I've got an Arduino. In this case, it's actually an Arduino Mega. And when it receives an MQTT message, it will put one of its pins to 5 volts, which then I'm running through an ISO optolator, which is basically just like an LED and a photocell, or photo transistor. And what it allows you to do is allows the microprocessor to be completely separate from the relay, and that is to protect it from any type of surge back, or if 230 volts, and because I'm in South Africa, were to run back to the microprocessor, it would actually stop it. So I'm also using it actually to ramp up the voltage to 12 volt in my case. So yeah, I'm running a microprocessor into opto-oscillator, which ramps it up to 12 volts, which then switches the relay, because most of my relays are 12 volt. Some of them are 5 volt, but most of them are 12 volt. Then on the software side, so this is the software which kind of runs on the microprocessor. In this case, it's actually the Raspberry Pi, and it's just a Python script that basically just checks the whole time if there's a button being pressed. If a button's been pressed, it detects the button, and then sends out a message through MQTT to say, this button with this ID has been pressed. And you can do more complex stuff with that as well. You can do combinations of buttons. So if you push 2 buttons or more together, it will send a different message, and you can have a totally different reaction to it. And then on the software side, on the microprocessor, which in this case Arduino Mega, I've got the MQTT library loaded, and it kind of just calls a function. So when it receives a message, it goes, hey, I've got a message, and then it decodes the message using like my special decoder software or whatever. And because the message is kind of encoded, it's gonna be something along the lines of like which Arduino needs to go to, what pin or what output needs to be turned on and off, and what must be turned on, must be turned off. Also, there are some pulse width modulation outputs, which if you don't know, it's kind of like dimmable. You can dim an LED with it, and so those don't have just in the on and off case, it's just simply 0 for off or 1 for on, but in the pulse modulation, it's 0 to 255. There's a whole different steps of brightness when controlling LEDs. So then there's also the logic. The logic software, which is the software which runs on the Raspberry Pi, and it does all the cool stuff. It's like the brain. It decides what it must do when you push that button. Because the way I've designed it, I can tell it to do tons of things. I can say when you push a button, if you push it after 5 o'clock, it will do something. If you push it before 5 o'clock, it will do something completely different. And you can program that all in. And then there's also, in this case, you can see there's an if statement. So this is that's also kind of like if past 5 o'clock, you know, do something. And then also, as you can see here, I've got a little block called other operations. So not only, it doesn't have to send a new message somewhere else, it can also do other operations, it can call other functions, it can also simulate a button being pressed. There's a whole bunch of things it can do. It can store memory stuff into the memory, it can retrieve stuff from the memory, because it is a database and it does have storage values. In that database, it has all the current outputs, and it can actually go there and be like, hey, what is, is light number 1 on? It can actually query that, and then the system will be a yes, and then it can do something, and no, it will do something completely different. There's a whole bunch of operations it can do. So that is the end of this video. Yeah, hopefully that helped you a bit about designing. When designing an automation system, I'll just add that just think about the goal, what is the whole purpose, and then you can start orienting all your hardware and software around that. I'll have a lot more videos about the software in the real world and how my software is working and how it's configured and stuff like that. And I am probably going to release the source. I just still haven't decided 100%, but it's probably going to happen because there's nothing really proprietary in there at the moment. So, thank you very much for watching, and if you want more videos like this, please subscribe, please comment. I would love to hear your feedback if you think my videos are rubbish, or if I need to improve them, or if you have any ideas or something you want me to cover, like a Raspberry Pi, Python, or something like that, or anything like that. I do have a spare Raspberry Pi here that I could use to do like a demonstration or something. Yeah, so thanks very much for watching. Please thumbs up if you liked, dislike if you disliked, and comment and subscribe. Thank you very much. Goodbye.